At Intrepid Metals' Corral copper project, every piece of the story matters, from infrastructure and geology to history and regional context. In this video, we bring those elements together. We'll explore the infrastructure that supports efficient development, examine drill core that reveals the system at depth, revisit historic workings that first exposed copper more than a century ago, and place Corral copper within the broader context of the renowned Bisbee mining district. Together, these pieces help illustrate the scale, potential, and opportunity emerging at Corral copper. Critical infrastructure requirements are available for the Corral copper project. With established road access, nearby rail, and reliable power, Intrepid Metals is positioned to advance this project efficiently and cost-effectively. Let's take a closer look. Corral is located in one of Arizona's most established mining districts, with infrastructure that would be costly to replicate. In the distance is the Apache Generating Station, a major power facility that serves the region. High voltage transmission lines run across the area, providing access to a reliable power network. Corral also benefits from excellent transportation infrastructure. Nearby dual rail lines provide direct access to the West Coast, while Interstate 10 and a network of secondary roads offers convenient access to the project. As we continue onto the property, you'll notice that access is straightforward. Well-maintained roads allow us to reach exploration areas by standard vehicle, making it easy to work throughout the project area year-round. Together, these infrastructure advantages support efficient exploration today and provide a strong foundation for future project development.
Okay, I just want to show you hole 23. It is one of the more spectacular holes here. This in particular was an interval of almost massive chalcopyrite, and you can tell it's got that really brassy color to it. And that's very unusual in the property because we've got almost 30 centimeters here, and there's more in the box there, of almost massive chalcopyrite, which is going to run about 29% copper in its pure state. Now it's mixed with a little bit of pyrite there, so it's going to be a little bit less, but that's going to run really good copper, maybe in the 20s, and we're going to have good gold in there too.
And this hole in particular ran a total of 113 meters of 1.5% copper and over half a gram gold. And that one section in particular was part of almost a 24-meter cut of 4.47% copper and 0.85 grams gold.
1% copper right now is worth, in the box, about $105 a ton. So we had $150 in the box just in copper. With the gold, which is half a gram, that's going to translate to, you're looking at $200 rock, and for what interval?
125 meters.
125 meters. So that's really a phenomenal intersection at today's prices.
This is a Ringo hole.
Ringo.
And then further to the north here, the very first hole we drilled up in what we call our holiday zone. The holiday very first hole was 124 meters of 0.52% copper and 0.35 grams per ton gold.
Translate that into rock in the box, you're looking at probably $50 a ton in copper and probably another $40 a ton in gold, gross metal value. And over that type of thickness, it's pretty impressive. Also consider this, these are probably 2.5 to 3 kilometers apart.
3 kilometers from this hole.
Yeah. So
when
you're talking about those type of thicknesses over that type of strike length, that's pretty impressive.
Historical earthwork all around here. There were several named small-scale mines that were mined in the early 1900s and again in the 1960s. And once we get down around the corner closer to Earp, you'll see a cement copper facility where they took a lot of this material and threw it into the vats just down around the corner.
So you can see the dumps over here. They're kind of a light brown in color. And and that's oxidizing sulfide. So there was a lot of very high-grade sulfide here. It oxidizes close to the surface. It turns the iron into an oxide like a rust, and that's the general color you're seeing. The reds and the browns are indicative of massive sulfide and oxidation.
And just right through this valley here was the old railroad route that circled down and around all the way to Douglas. So again, here we are at the holiday zone, and it's important to point out, as Chris mentioned previously, we've got this mineralized trend that we now know of that starts at here in Holiday. It goes about 3 kilometers to the south, all the way to Ringo, and we still have tremendous search space for additional mineralization.
And also, another aspect of this is this is between 300 and 400 meters wide. So it stretches 3 kilometers to the south, about 300 to 400 meters wide. There's a lot of oxidizing sulfide here. It produced acid. It's very likely that we've got some sort of an enrichment blanket, oxides or black copper oxide down below us. And that's an ancillary part of this deposit that we really haven't investigated yet. And just another item to point out, just behind us, opposite direction, we've got Mexican Hat, which was drilled in the 1990s, and that is probably about 500,000 to 900,000 ounces of gold, owned by another company, but it just goes to show you that we're in proximity to gold-only deposits as well. So it's a gold-enriched district. Probably different deposit types. Nevertheless, we've got gold here at different ages.
So here we are at the ERP area of the project. So in behind here, you can see a lot of the old workings as well. We drilled a number of holes. We just left the Holiday area, which is about 1.5 kilometers to the north. And next we're gonna rotate down into the Ringo zone, which is about 1 kilometer just on the other side of this hill over here. So that kind of sets up that 3.5 kilometer trend of known mineralization that we touched on earlier.
We're standing on a gold mine. Okay, well, we're at the site of 2 of the holes that we looked at the core shed. And we're sort of at the southern edge of the drilled area. And this was hole 11 and hole 23 is over here. And we kind of discussed the grades at the core shed, but we were looking at a few 100 meters of really good rock.
Yeah, hole 11 again, when we start talking about over 100 meters of 1% copper, that's something that really kind of separates us, knowing that it's starting right at surface. And as Chris mentioned, we're in around the heart of Ringo in many ways. So to the north, we pass through the ERP area and up into the Holiday area. And then just a little bit further south, just on the other side of the ridge here, is our new planting zone, which we're really excited about. And then a little bit further towards the west, you run into a new area. We haven't quite yet named it, but it's showing a lot of potential for porphyry mineralization. Chris talked about the value of the rock. So where we stand today on the top of Ringo and thinking that 20 meters below us is where we get into massive copper grades. To Chris's point, no one would have ever known. It came from some of the historical geophysics that was done, and that mag signature that Chris talked about, some of the magnetite in the core, was why they likely drilled here in the first place, which provides us ample search space moving forward, because a lot of the mineralization is not just tied to some of the magnetic zone, and we proved that by drilling other areas.
And at these thicknesses, it's probably going to be an open pit. But you can imagine if we've got 200 meters, its gross metal value is probably over 100, 150, maybe even $200 a ton. We have to move all that. And to move it, say the gross metal value is, say, $200 a ton, which is good for an open pit. It's excellent. The recovery of that $200 a ton is probably restricted to maybe 90%. Most copper deposits recover about 92% of the copper, more or less. And then the gold is a separate recovery, which has to be worked out in the metallurgical lab. But when we start this, we look at those numbers. To mine it, you're probably looking at $3 a ton to break the rock and move it. You take it to a mill where you recover the gold and copper. That's another process. That might be another $15 a ton. And then to refine it, you're probably looking at another $20 a ton. Even with all those expenses, the mining, the milling, the refining, it still leaves us plenty of room to make a profit out of it. And that's always what we're looking at. What is the final value of all that material? It's a volume grade problem. This is the Bisbee district in southern Arizona, and it's what we consider to be the analog or target for what we have over at Corral, which is probably about 40 kilometers away. Bisbee was mined from probably before the turn of the 19th century until the 1970s. And we're looking at the Lavender Pit in the background. It is the center of the district, but it's not where the highest grade copper came from. The Lavender Pit is in an intrusive, and the highest grade mineralization at Bisbee came from the surrounding limestones, where these very high grade bodies, carbonate replacement deposits, copper rich, were found. And that was really the start of the American copper mining business. It started at about the same time as electrification in the United States, so there's a huge demand for copper, and this was probably one of the highest grade copper deposits in the country. The pit itself was low grade as opposed to the carbonate replacement deposits in the limestone. The carbonate replacement deposits, the oxides and the sulfides, were probably running multi-percent, maybe even maybe 20% copper in some areas. Bisbee was a multi-generational 8 billion pound copper deposit. And what makes it different from other copper deposits in Arizona is, number one, it's older, and secondly, it had 3 million ounces of gold in it, and that is rare for Arizona deposits. I'm just going to swing around here. I want to show you the outcrop. So at Corral, we had a very red outcrop at the surface, and that was oxidizing pyrite, and that's what you see with the red rocks. That was all pyrite and chalcopyrite that once outcropped. The pyrite oxidized, it produced acid, sulfuric acid. That sulfuric acid leached the copper out of that rock at the surface and concentrated it in the rocks just below. The gray rock is due to disseminated pyrite and chalcopyrite. Not highly mineralized, but it was enough to mine at Bisbee after the high grade was taken out and all the capital infrastructure was put in. It could mine lower grade ore. And that's exactly what you have here. Oxide at the surface, you go down probably 50 meters, we get into the sulfide, the enriched cap. That's what we've got right behind us.